All right, so hopefully this thing is working because I don't want to check right now. So you guys should be here with me, day 2. So today is going to be the start of really going into what an integral means, which is extremely important. Just like when we started really learning what a derivative meant, it was very important, and then that just kept coming back over and over and over again. So same thing for this is the start of what's going to keep repeating itself throughout the semester. All right, so this looks kind of different from yours, meaning your boxes are way smaller. It's just because I have to write big so that you guys can see it. And I am going to do a graphical explanation to the right of the difference between the two. Okay? So to start off, let's give a definition. So displacement is exactly the same thing as your net signed area. So first start out with net signed area. And I'm going to actually add a little bit more to what it really means. That's the shorthand version of what the displacement will be. Okay? Displacement essentially is very similar to the net signed area. And I'm just going to add a little bit more. Bounded between the curve and the x-axis over the interval a to b. So if I ask you to just very easily find the integral from a starting place to an ending place of f of x dx, that's essentially what the displacement will be. It'll be a little bit different than total area. Okay? So your displacement signed, it means that your answer for this can be positive, it can be negative, or it could be 0. Those are the 3 types of answers you can get for that. Whereas your total area is exactly what it says. You're looking at a shape, you're looking at the bounded areas, you're not going to care if they're positive or negative. All you're going to care about is how much the areas are, and you're going to just put them all together. That's what total area is, exactly what it says. So total area is always positive. And so this is where we do not care if area is below x-axis. There's no sign. We don't do a sign for total area. So I'm leaving a little bit of space because we're going to write a very long integral inside of here. So I'm going to give you a little graph. If you could kind of squeeze it on top, it'll be a small little graph. We're going to do from A to B. And I'm literally just going to go kind of do like a sine curve. And I'm going to say that if I asked you to find the area of that piece, we're just going to call it 5. If I ask you to find the area, not net sign, just the physical area from, and we'll call this C, from C to B, that area is also going to be 5. Okay, so we'll put those numbers in. Therefore, if I asked you to find the physical integral from A to B of f of x, which is that purple curve, how much would my net signed area be? So net means if you have positive versus negative, sign means yes, you talk about positives and negatives. Put them together. So again, the net signed area would be how much? 0. I'm going to ask 2 more questions without writing them down here. What if I ask you to find the integral from A to C? How much is that integral? All right, Nathan? Positive or negative? Positive 5. If I ask you to find the integral just from C to B, raise your hand if you know that. Joshua? Negative 5, why? Because it's below the x-axis, all right? And then if I ask you to find the integral from A until B, Ariel, the answer was 0. Because you had the positive 5, you had the negative 5, the net, you have $5, you owe $5, your net is $0, okay? So you think of it like money, same thing. So now we're going to talk about total area. Total area doesn't care that this is underneath. We just care that there's area. So if I look at the shape and I say, what's the total area from A to B? What's that number going to be? 10. We don't care that the c to b was underneath, all right? But I'm going to actually have you write down the integral. Total area, big pain in the butt. Why is it a pain? Because you can't just say, oh, I'll just go from a to b. You're going to have to split up the integral. So how would we do it? We're going to do the integral from a until c first, f of x dx. I'm going to leave a little bit of a gap, small gap, because we're going to put a sign there. And I'm going to do the second integral, which is from c to b of f of x dx. Here we did 2. Displacement, we did 1. Displacement is always 1. You just go from start to end. So total area is a big pain because you're going to have to do an integral for every piece of area that you see. So I see piece here, and I see a piece here. That means I have 2 integrals that I have to do for total area. So I'm going to ask, and we actually did the question already. If I put a big old plus in between, the question that I'm asking you then becomes, find the net signed area from A to C, find the net signed area from C to B, and add them together. It's going to be 0. So if I put a plus here, it ends up being the exact same question as displacement, but that's not what we want. We want the total area. So you do a minus for any part that's negative. So here, from C to A, this piece was positive. But from C to B, this part was negative. And so because it's negative, we're literally going to minus that piece. What happens when you minus a negative? Makes it positive. Sorry, this thing is chirping like a cricket at me. That's odd. All right. Yes, Danny. Yes, if I kept continuing on and I made a few more pieces, that's how many more of them I would need. All right? So this answer, when you're all done, always positive. If you get a negative answer, you did something wrong. Automatically, your total area, if you get a negative answer, it's going to be wrong. All right. Any questions between the displacement and the total area? Joshua? Yes. No, it can't be. The displacement can be, because the positive pieces and the negative pieces will cancel each other. But something like this, it doubles. Okay, good. All right, so you got a few questions. You have 2 graphs. We're going to do this one together because it's a little bit harder than this one because of how many pieces there are. So when we start and talk about integrals, I want you to take your endpoint. So this said it went from -2 until +9, and we're going to put our endpoints, and I want you to close the figure, which means take the endpoint, go towards the x-axis, take the endpoint, go towards the x-axis. I want you to close up the figure so you can physically see the pieces. The other things that are really important, notice those breaks, which are called the x-intercepts. That's where all the areas break up. Those are going to be important. So we're going to go in order. First question says, is the integral over AB positive, negative, or 0? So let's just start off with finding the integral from the starting, which was, I think, -3. The ending was +9. And we're going straight across, which means net signed area. So plain old integral, net signed area. Will it be positive, negative, or 0? What do you guys think? Here, overwhelming negative, because there's definitely more underneath the x-axis. So that would be negative. Total area, way harder question. How many integral statements will I have to make? 4, because there's 4 pieces. So we'll do them in colors. Let's start with orange. So that would be the integral from -3 until -2 of f of x dx. Is that a positive integral or a negative integral? Negative. So what do I put in front? A big old negative. All right, next piece we'll do in bright green. That integral goes from -2 until +1. Sorry, green's hard to see, huh? Is that a positive integral or a negative integral? It's a positive integral, therefore, you're literally going to put a plus. Next one in blue, big piece down here. Positive or negative? Negative, so you put your minus integral from +1 until +8 f of x dx. And then the very last piece, which we'll do in red, That one's positive, so I'm going to have to squeeze it on the second part of the line. And that would be from 8 to 9 of f of x dx. 4 pieces that you would have to find. I want you to be able to write out the integral. I think even in your homework, you don't really have much practice on this. It's because knowing this will make a lot of stuff easier later. So I'm showing it to you a little bit early. So then at the bottom it says total area by calculator. So on your homework, the last question or two that I gave you that asked you to use your calculator, I'm going to show you how to do that. If you have a newer calculator, you're literally going to do exactly what this looks like. You're going to have a box down here, a box up here, a box here, and you're going to fill those 3 things out. Whereas if you have the older calculator, that notation I'm going to write here for you. So to find the integral, you're going to do Math 9. All right, so I'm actually going to write the fn up here because it's going to be a little different. So to do the integral, actually I can squeeze it right here. So if I wanted to do this integral in the calculator, I would take my calculator and I would do fn, which is Math 9, parentheses, the function, which is y1, looks just like what we did before, parentheses, when you do your derivative, what do you have to do next? X. And when you did your derivative, we did the derivative at 5. We did the derivative at -2. We did the derivative at pi. Can you do the integral at -2? Think about what integral means. Can you find the integral at -2? No, because you would be finding an area at a number, at a point. There's no area to be had because there's no width. All right, so following suit, you need an A and you need a B. And yes, the order matters. You got to go in order A to B. So I'll write it big one more time here. fn int of y1 comma x. Where's her back? Ooh, there it is. X, A, B. Very similar to derivative. Okay, so Math 9 is where you find it. So total area, slightly different, because if you do this, you're going to find this answer. It will be positive, negative, or 0. Total area is actually way easier in the calculator. I want to take a look at this. Let's talk about what it did. It took all these pieces down here and said, oh, they're negative, but we want them to be positive. How could I take a graph and only move the negative pieces? Absolute value. If I took the absolute value, then in bright yellow, wouldn't the graph look pretty much like that? And we wouldn't care about the bottom piece anymore. You would be looking at the yellow, the green, and the red. And that would be the same answer as this. Do we agree with that? Okay. So that's what we're going to do here. Your calculator can do absolute value. You guys can't by hand. Just like derivatives, we don't do absolute value by hand. Ever, ever, ever. So we are going to fn int parenthesis. If you have the nicer calculators, I'll show you that in a second. You're going to use the absolute value button. And I'm blanking on where that is right now. Math move over, is it? Math move over, number, and then 1. Okay. So absolute value, y1. Then you do the same thing, x comma, and we're going to go -3 to 9. So you just add in the absolute value. So that takes the negative part of your graph, flips it up, and then afterward takes the integral from beginning to end. It doesn't break up the integrals. It just does it from beginning to end. You just can't do that by hand. That's why we break them up when we do it by hand. So I'm very specific. I say by hand, by calculator. This only works on the calculator. You can't do it by hand. You can't take the integral of absolute value. Yeah, because you guys can't take integrals just yet. You haven't learned. So derivatives, when you first learned them, you drew a tangent line and then you counted how your slope. You went, oh, up X amount over. And that's how we found our derivatives in the beginning. Or I made you use the calculator to do n deriv. Same thing. I'm not teaching you how to do it just yet. The concept first, and then we'll do the calculation of how to do exact. All right? So I want you to fill out the right column. It's a little bit easier because I only have one x-intercept. So if you guys can do that one from -2 to 14, when you are done, you can look up and see if your answer matches my answer. That looks just like this. So it's the same notation. So instead of just f of x, you need the absolute value of f of x. All right. Any questions on that right side? If you get a calculator, I want you to use it. If I tell you you get to use the calculator, then it means I'm making you practice with the calculator, because you guys forget. And then when the test comes, you don't use it, and then you can't do a lot of the problems. They take too long. Calculator problems are made so that if you try to do it by hand, it's either impossible or way too difficult, one or the other. Okay? All right, so is that light still blue? All right. Is there a light that's blue on either side? Okay. All right. So I'm going to have you skip, and we're going to do example 5. And if we have time, I'll go back. All right. So example 5 has 4 problems where you're going to be going through and finding integrals. But now there's physical functions. And if you remember, I said you don't know how to do that. You haven't learned how to find the integral of actual functions yet. What this means, and for tonight's homework, and probably even tomorrow's homework, you're doing everything by area. It's the only way you know how for now. Okay? So it means that each of these will make some type of shape. And it'll be a shape that you know how to find the area of. So to start off, anyone know what graph that makes? Other than Joshua. Anthony. It is a semicircle. So let's prove that it's a semicircle so you make sure you get it right. So I'm going to actually take the integrand. The integrand is the function that you're taking the area of, the net signed area. You're going to call it an actual function now. And then I'm going to actually get the x squared over to the left side to prove that it is a circle. So square both sides. And then move the x squared over. And now you can see that it is x squared plus y squared equals r squared. So you end up with a circle. Radius of how much? Exactly 2. X squared plus y squared equals r squared. So the radius is 2. So we're going to draw that. Oopsie, I missed it. There we go. So then we're going to look and see where did they want me to find the area from -2 to 2, and you're going to shade the area that they want you to find. That's just to make sure that you don't make the mistake, because I could ask you to do the integral from 0 to 2, and then you want to make sure that you actually do only the piece they asked for. Joshua? Not right now. I know. All right, so this is a semicircle, so we're going to do 1/2 pi r squared. And we're doing the entire semicircle. So the radius is 2. 2 squared is 4. Divided by 2 is 2. So this guy, the answer becomes 2 pi. I really want to make sure that for whatever shape you get, you always take the endpoints and close it. This one was nice. The endpoints closed out the semicircle. You always closed your shape. Okay? Don't guess. I taught you how to do that. Endpoint, endpoint, and go towards the x-axis. That is extremely important. Okay? All right, letter B. What shape does negative 2x plus 4 make? It's a line. Okay, so we're going to graph the line, and then from there we'll kind of figure out where we're going to be finding the area, and then I believe I'm going to make that scale really big. All right, so that's 1, that's 2. We know we're going to be taking the area from 1/2 to 3/2, but I'm just going to graph it how I graph lines usually, which is slope and y-intercept. So I'm starting out at 4. Slope of negative 2 means down 2. To the right 1. So pass 1/2 and go all the way over to 1. Down 2. Pass the half mark and go all the way to 1. So there is my line. Now that that's my line, I just have to figure out what area I'm actually finding. So 1/2, you're going to go make a point. And I said take the point, go towards the x-axis. Take the point, go towards the x-axis. Now you have your bounded shape. And you want to shade so that you don't forget what you're taking the area of. You don't want to do the whole triangle by accident. Okay? So, what shape did I make? A trapezoid. Trapezoid has one set of parallel lines. Those are called the bases. The parallel lines are always your bases. The side, that other side is the height. Perpendicular between the two bases always makes the height. So it's actually laying on its side. It's not standing on its base. So trapezoid. Area formula is 1/2. The height times base 1 plus base 2. The other way to see it is the average of the bases. Average meaning add them, divide by 2, and then multiply by height. That's the formula for area of a trapezoid. You 100% don't get that on the AP, so you do need to know that area formula. All right. So what are the values? We get 1/2. The height is that piece, and that height is 1. The two bases, base 1 is here, base 2 is here. So you don't guess. Please don't say, that looks like it's about 3, so I'm going to write 3. You double check and make sure it's exact, because guessing will get you a bunch of wrong answers. All right, so 1/2, we substitute into the formula, and we do end up with 3. You always check, though. Please check, because there are times that the answer is 3.1. Okay, slightly off. Same thing for this point. I'm going to substitute in 3/2 into my equation, and I get 3/2, comma 1. So there are my bases. My base 1 is 3 high, and my base 2 is 1 high. And so the answer to this one, I believe, is 2. All right, there's 2 others that I have with absolute values, because I wanted you to see absolute values. And I also wanted you to see something with a discontinuity. So, absolute value of x over x. If you know what that graph looks like, go ahead and graph it. If you don't know what it looks like, make a table. Make a table from -1 to 2. The next one. I'll give you a really big hint. It does not look like a V. So if you have a V, it means you did not make a table and you did not check points. Let's use a little common sense. Let's take away the absolute value. X over x. 1. What does the absolute value do? Takes a number that's negative, makes it positive. When it's negative, x is, you get -1, but when it's positive, x is, you get +1. Common sense there. If common sense doesn't work, You sit there and you make a table, and when you make tables, you don't just go by integers. You use some halves or thirds or decimals to double check that you're right. So for this guy, I'm going from -1 until 2, and we just figured out the values. So point here until discontinuity, discontinuity. Discontinuities don't matter as long as you can bound the shape. The only discontinuities that do matter, infinite. Because infinites keep going up or keep going down, the area keeps increasing, and those you can't do, but these kinds you can. Because I'm going to take from endpoint to the x-axis, endpoint to the x-axis, and that discontinuity is a point discontinuity, so you get to do this. And you get to just... And I did the same thing, point to x-axis, point to x-axis. Now you got two shapes, which are rectangles. Makes it very easy. So, how wide is this rectangle? 1. How low is the rectangle? 1. What is the, and we're doing an integral, plain integral, not total area. What is the integral value from -1 to 0? No. Just so you know, that's what I heard. So my two answers will probably be +1. Anyone have an answer for that? Raise your hand. And my other answer is probably -1. Anyone have answers with that? Raise your hand. Raise your hand if you think the answer is -1. Raise your hand if you think the answer is +1. I have like 7 hands. There's definitely more than 7 of you. So my question again, we're doing a plain integral, not total area. So the integral from -1 until 0 was the first part that I'm asking you. So the integral from -1 to 0. Is it +1? Raise your hands. -1? Raise your hands. Yes. We're doing a net signed area. Does everyone see it doesn't say total area anywhere? So the net signed area would be -1 here. The net signed area from 0 to 2 will be how much? 2. The actual integral, which is displacement, which is net signed area, is how much? It's the -1 plus the 2, which is +1. The net signed area, which means you have $2, you owe $1. How much do you have left? $1. Not total area. Please don't confuse those, because that is the whole point of my lesson today. Do not confuse total area with plain integral. This said just go from -1 to 2. So the answer to this is +1. I'm going to even do that. I did not use extra negatives at all. Okay? Let's look at this guy. This one's factorable. So you end up with a minus 2, a plus 2, all over a minus 2. What does the graph actually look like? Annie, what do you say? What does the graph look like? A plus 2, which is a line. What about that canceled term? What does that give us? A whole, which is okay. That's what we just learned. So a plus 2, let's go up 1, 2, and then we're going to go all the way to 5. So 3, 4, 5, 6, 7, down. All right.
Teachers and students, please pardon this interruption. This announcement is for students in the ESOL program. If you are taking an ESOL class level 1,
Did I totally do that wrong?
5, or if you were a former ESOL student, please make sure to look at the rosters posted on the main office windows. If your name appears on one of these rosters, you will need to report to your designated custom location tomorrow morning at 7:25. Thank you.
All right, and then at 2, let's see. The discontinuity is at... Did I mess this up? Discontinuity is at +2, which I'll go back and fill it in. All right. So discontinuity is at +2. But it won't matter, because I'm going to find the bounded area. Please make sure you do exactly what I said. Endpoint, down, endpoint, down. And in this case, you're finding, not total area, sorry. You're finding the net signed area. So net signed area says you're going to find the area of this triangle, and that'll be negative. You're going to find the area of this big old triangle, and that'll be positive. But you're literally just going to add them. So let's actually put in the values real quick before you guys leave me. Nope. Yeah, you kind of jump over that little piece. All right, so what's the area of this guy? It'd be 1/2. The base is 2. The height is 2. Actually, we can actually say -2 if that makes it any easier for you. So that's -2. This one would be 1/2. The base, I think, is 7, and the height is 7. So that's 49/2. So what is the actual answer to the integral? We leave this negative because we're not doing a total area. And the actual answer would be -2 plus the 49/2, which is 45/2. All right? I'm leaving that negative because I'm not doing a total area. What's the answer to the total area? That would be 53/2. Is anyone confused on the difference between? All right. That's everything.